Hi, I'm Miss Hall.
Hi, I'm Ethan.
Hi.
Ethan!
Okay. And this is lesson 59, Solving Rational Equations, Part 2.
ABC!
Here's the problem from example 3. We're going to begin by multiplying every term by the least common denominator. So there's 3 denominators, and I can tell by looking at them that the least common denominator is x times x minus 5. Least common denominator. So we're going to multiply every term by the least common denominator. We have 1 over 1 minus 8 over x minus 5 equals 3 over x. Okay, least common denominator. So we're going to multiply this 1 by x times x minus 5. We're going to multiply this 8 by x times x minus 5. Multiply this 3 by x times x minus 5. So I've now multiplied every term by the least common denominator. I'm going to simplify each term. This first term will become x squared minus 5x. I'm just going to keep it in parentheses for now. I can get rid of this common factor of x minus 5. So I'm left with minus 8x. I can get rid of the common factor of x, and I'm left with 3 times x minus 5. Okay, so by multiplying every term by the least common denominator, I get rid of the denominators, and now I have an equation that I can solve. Don't need the parentheses anymore. Minus 8x equals, distribute the 3x minus 15. This is a quadratic. I see I have an x squared. So I'm going to move everything to one side, make one side 0, one side have all the terms, so I have x squared. This is negative 13x. Minus 3 is negative 16x plus 15 equals 0. I factor my quadratic. X minus 15, x minus 1. Therefore, x is positive 15 and positive 1. Always a good idea to look back at the original equation and make sure that neither of the x values will give you an undefined denominator, right? So if I have 15 minus 5, that's not 0. 1 minus 5 is not 0. 15 and 1 are not 0. So my answer here is x is 15 and x is 1. Okay, here's example 4. Same steps. We're going to begin by identifying the least common denominator. Least common denominator here is x minus 3 times x plus 3. As least common denominator. So I'm going to prepare to multiply every term by that least common denominator. And as I'm rewriting it, I'm just going to factor the x squared minus 9 denominator. Right? That's a difference of squares. Okay, so now I'll bring x minus 3 times x plus 3, x minus 3 times x plus 3. Right, I'm keeping the equation in balance because I'm multiplying every term by the same expression. X minus 3 times x plus 3. And now I can divide out common factors for each rational. X minus 3, x minus 3. So I'm left with 6 times x plus 3. X minus 3, x plus 3, 8x squared. This is a minus 4x times x minus 3. Okay. Continue solving. I'll get 6x plus 18 equals 8x squared minus 4x squared plus 12x. This is a quadratic, so I'll get set one side to 0. Move all the variables to the other side. Here I'm going to get 4x squared. Subtract 6x from both sides, get plus 6x minus 18 and 0. I'm going to take out the GCF of 2, so it's going to be 2x squared plus 3 minus 9 plus 3x. And now I have, it's going to be 2x and x. And it's going to be plus 3 and minus 3. Let me just make sure. Negative 3, positive 3 multiplies to negative 9. Good. I get 6x minus 3x is positive 3x. Great. And now my x values are positive 3 halves and negative 3. And I'll finish by checking for extraneous solutions. Would either of these x values make the original denominators, one of them or any of them, 0? And the answer is yes. Negative 3 is an extraneous solution, so I get rid of it. It would make the second two terms undefined. 3 halves does not make any of them undefined, so we only have one x value here. X is 3 halves. You don't need to identify that negative 3 is an extraneous solution, but I'll write it for our notes purposes. Extraneous solution. And so we only have one x value. That's our answer.